Hi, in this video we're going to be doing a review of salt hydrolysis. Now salt hydrolysis is basically when a salt is placed into water and then you need to predict if it's good, you need to tell how acidic or basic it is. Now let's say we need to predict how acidic, if a solution will be acidic or basic when you put a salt of Na2HPO4 into water. So now what will happen is let's set up the reaction. So what happened is this is going to break down into Na2 plus. Nope, this is going to break down into 2Na plus and HPO4 2 minus. In this case, Na is going to be a spectator ion and it will not affect the pH. Because the Na is a conjugate of basically NaOH is a strong base and Na plus is going to be a weak conjugate acid, it will be a spectator ion. It will have no affinity for water. So Na is going to be a spectator ion. Now we're going to grab HPO4. Now HPO4 is amphoteric. So it can be HPO4 2 minus plus H2O. This one can this one can accept a proton and form H2PO4 minus plus OH minus, or it can act as an acid and donate a proton, forming PO4 3 minus plus H3O plus. So how do you know which reaction will be? Well, first of all, this produces OH, so we'll be using Kb, and this produces H3O plus, so we'll be using Ka. And basically when you compare the Kb and the Ka, so what is the Ka? Let's do the bottom one first. What is the Ka of HPO4 2 minus? HPO4 2 minus H3PO4. All right, and what are the product reactants? We have HPO4 and a PO4 3 minus. So we'll be looking at Ka3. No, Ka3, the first one. 4.8 times 10 to the negative 13th. So the Ka for this one is 4.8 times 10 to the negative 13th. Again, because our products and reactants include PO4 3 minus and HPO4 2 minus, that's why we use Ka3. All right, so it'll be Ka3 over here. This one we're dealing with HPO4 and H2PO4 minus, HPO4 2 minus and H2PO4 minus. So in this case, we'll be doing Ka2 based off what products and reactants we have. And, Kb2, all right, Kb2. Now, what is the Ka2 of this? Is going to be 6.2 times 10 to the negative 8th. Now, that is Ka. So we're going to use our calculator. 1.0 e to the negative 14th divided by 6.2. 6.2 e to the negative 8th. That will give us a Kb of 1.6 times 10 to the negative 7th. Now we compare which one's bigger. Alright, so obviously as you can see, times 10 to the negative 7th is significantly bigger than times 10 to the negative 13th. So because the Kb of this is bigger than the Ka of this, because Kb of equation 1 is greater than Ka, so this equation is going to be more favored when HPO4 2 minus is placed into water. And now our question is, will the solution be acidic or basic? Well, this produces an OH minus. This produces an OH minus. So we know that our solution will be basic after we place N2HPO4 into water. Now let's quickly review net ionic equations as well. So let's say when we have equal volume of 1.0 molar of K3PO4 and 2.0 molar of HBr is placed into water, right? So what we're going to have is K3PO4. We're going to have the molar ratio is 1 to 2. So K3PO4, and we're going to have 2HBr. Now this will just form 2H plus 2Br minus. This is going to form 3K plus PO4 3 minus. K plus, that's a weak conjugate acid. Now weak, we're not going to count it. HBr is a strong acid, so Br minus is a weak conjugate base. So we're not going to include this either. So our reaction is just H plus PO4 3 minus. So we're gonna have 2H plus PO4 3 minus is gonna form H2PO4. And H plus is technically H3O plus. H plus and H3O plus is the same thing. So this is gonna be double arrow. It's gonna be H2PO4 minus plus plus 2H2O. Right? Because we used up 2 of the 6. So we'll have 2 of the 6 H over here, and we'll have 4 H's remaining. So this is our final equation. And what's going to happen to K, our BR? And that is going to be spectator ions just sitting around. And that's it for this video on salt hydrolysis. Thank you for watching.